All right, if I'm required to find this slope of a line connecting 2 points and I don't have a graph, I have to use what's called the slope formula, which is this guy right here. Now, before I use the slope formula, I'm going to label my points x sub 1, y sub 1, and x sub 2, y sub 2, and now I just plug them in. Y sub 2 is negative 2 minus y sub 1, which is 8, x sub 2, which is 7, minus x sub 1, which is negative 4. Negative 2 minus 8 is negative 10. 7 minus negative 4 is positive 11. And I end up with negative 10 over 11. Done.
Find the midpoint. Now we're doing this graphically. The midpoint is exactly what it sounds like. It's a point in the middle of a line segment. We have an end point here at negative 4, 1, and we have an end point here at 1, negative 4. All right, so the distance between this guy to this guy is 4, so the midpoint is going to be somewhere in the middle of it around here. This goes from positive 1 to negative 4, which means the distance here is 5. So somewhere in between is going to be my midpoint. Now, we like to call midpoint M, and it looks like if I were to list out what this point is, I would go negative 1 to get there, down 1.5. So my midpoint is going to be negative 1, down negative 1.5. Now, if you're thinking, you sounded a little insecure about that, sir. Is there a way we could do that algebraically, like math and stuff? There sure is. That's the next video. Make sure you watch that too. But this is just graphically. And we were able to look at the middle of everything by kind of eyeing it up, and that looks about right to me because it is right. So there's your midpoint. Find the midpoint. No graph, and instead I have 2 points, 5, 2, negative 4, negative 3. The midpoint formula says let's take one of these points, doesn't matter which one's which, and call it x1, y1. Let's call the other point x sub 2, y sub 2. The midpoint formula is this. It's a big point, and the x value is going to be x sub 1 plus x sub 2 all over 2. And if you're thinking, that's like the average, it is like the average. Average means middle. Okay. Y sub 1 plus y sub 2 all over 2 gives me the midpoint for the y value. Now it's just a matter of plugging stuff in and doing a little bit of math. All right, so x sub 1 is 5 plus x sub 2 is negative 4 all over 2. Y sub 1 is 2 plus y sub 2 is negative 3. All of that over 2. 5 plus negative 4, or 5 minus 4, is 1, so 1 over 2. 2 plus negative 3, or 2 minus 3, is negative 1 over 2. So we'll slide that negative out there because I don't have enough space to draw another thing underneath. And so that's my midpoint. You know, the kids tell me that this is really mid. And I'm like, it sure is. Mid means like average, I guess. I don't know. I'll check Urban Dictionary. Like and subscribe. Find the distance between these 2 points. All right, so I got that point right there. I've got that point right there. I really can't get out a ruler and measure out how long that is. It's neither horizontal, it's neither vertical. Plus, I don't want a ruler because Jesus is the only ruler that I care about. Or the president. Or the King of England. But more Jesus. So what I can do is I can do this. I'm going to draw a perfect line, as you can see me making right there and right there. And what I've just created is a poorly drawn right triangle. I know that this length is 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces long. And I know that this one is 1 space long. And if I'm trying to find the missing side of a right triangle, I'm going to use what's called the Pythagorean theorem right there. There you go. Now, what's A, what's B, and what's C? Well, in a right triangle, the longest side is always going to be C, and the longest side is always going to be the one opposite of the right angle. Which one's A, which one's B? Doesn't matter as long as the longest side is C, because you're just going to square them and add them anyway. So let's call 9A, let's call 1B. So when I plug it in, I have 9 squared plus 1 squared equals C squared. I have to get C all by itself, but first I can do a little bit of PEMDAS over here. So 9 squared is 81. 1 squared is, let me get out my calculator. 1 times 1 is 1, and then that still equals C squared. 81 plus 1 is 82. That equals C squared. Square root both sides. Remember, if I want to undo a square, I square root both sides. And so C equals the square root of 82. Now, depending on what teacher you have, they might be like, well, I need you to find out the decimal to the nearest whatever. So the square root of 82 is like 9 point something. If you have a teacher that says you need to break this down and turn that into something times the square root of something, you can't do anything here. 82 is 41 times 2. You can't break that down any further and bring stuff out. So we're done. C is the square root of 82, or 9 point whatever it is. But that's what we did. We used the idea of a right triangle to find out the distance of that dot to that dot, which ended up being a little over 9, which makes sense. Dollars and cents. Find the distance between the 2 points 8, 5 and negative 1, 3. Now, I could graph that and do what I did in a previous video and make a right triangle, but I ain't. I'm going to use what's called the distance formula. The distance formula says I'm going to take a big square root. I'm going to do in one square root x sub 2 minus x sub 1, square it. I'm going to add y sub 2 minus y sub 1, square that. That's the distance formula. I'm going to label u x sub 1. I'm going to label u y sub 1. I'm going to label u x sub 2. I'm going to label u y sub 2. Now, if you're looking at that and saying, man, that awfully looks like Pythagorean theorem, but with points instead of lines and sides, you're absolutely right. It is the Pythagorean theorem. So a lot of similar stuff is going to happen here where we square things and maybe square root it. Maybe something nice happens, maybe not. I don't know. But this is the distance formula. And if you look online and say, oh, I saw online that this is supposed to be x sub 1 minus y or x sub 2. Doesn't really matter because whether this is positive or negative, once you square it, it's going to be positive anyway. Who friggin' cares? So D is going to equal a big square root. Inside the first parentheses, I have x sub 2, which I called negative 1, minus x sub 1, which I called 8. Square that, plus y sub 2, which is 3, minus y sub 1, which is 5. Square that. Inside the square root, I have negative 1 minus 8, which is negative 9 squared. See what I mean? This is just going to become positive anyway. Plus 3 minus 5 is negative 2 squared. Okay, let's bring that up here. The square roots are getting smaller. Negative 9 times itself is positive 81. Negative 2 times itself is going to be 4. And that gets me the square root of 85. I'm trying to think, can I break that down any further? No, I'm trying to think like if I go and make a factor tree and try to rip it apart, that gets me, 17 and 5, so that does me no good. So this is it. I'm stuck. I'm stuck at an ugly number. Now, if you had a teacher that said, well, what is that as a decimal? It would be 9 point something, because I don't know what the square root of 85 is, but I do know that the square root of 81 is 9. So something that's bigger than 85 is going to be something that's bigger than 9. So 9.2, blah, 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 blah. But whatever your calculator says, I'm not a calculator. I'm a human. I'm a human being, and I have needs. And I need you to smash that like button. All three of you watching this, thank you.
What up, what up? All right, I am looking at a picture of what looks to be a quadrilateral four-sided figure on a coordinate plane, and my job is to find out if it's a rhombus, a rectangle, a square, or a combination of the three, or none of them. So this is what I need to do. In order for it to be a parallelogram, first off, because all of these fit under the parallelogram umbrella. In order for it to be a parallelogram, opposite sides have to be parallel, which means their slopes have to be the same. So let's first determine that. Let's find the slope of each guy just by doing rise over run. So I'm going to go from J to K, up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7. So my slope is, what did I say, 6 over 7. That's my slope from J to K. My slope from L to K is up 1, 2, left 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 2, left 9. My LM is up 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7. So that's 6 over 7 again. And I have a feeling this is going to turn out nicely. By the way, you're going to hear my clock say 10 o'clock in a second. 1, 2, over 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So we definitely have a parallelogram here. Now, what makes a rhombus is all four sides have to be the same. This is where it gets annoying. In order for all four sides of it to be the same, we need to use Pythagorean theorem to determine if that side... Now, I know these two sides are the same. 10 a.m. I know these two sides are the same, and these two sides are the same. Well, I mean, these two sides are the same as each other, and these two sides are the same as each other. But are all four sides the same? So let me find out the length of this side right here. If I've just pretended that this is a right triangle, I know the qualities of this right triangle. That's a side of 2, and that's a side of 9. So Pythagorean theorem, and I know I could use point formula or distance formula, but I hate distance formula. So I'm just going to use Pythagorean theorem, which is a squared plus b squared equals c squared. That's a lot friendlier in these cases. I have a side of 2 and 9. So I'm going to do 2 squared plus 9 squared equals c squared. That becomes 4. That becomes 81 equals c squared. Add them up, you get 85. 85 is equal to c squared. Take the square root of both of them, and you get 9 point something, but I'm just going to leave it as a square root of 85 because whatever this is, this has to be the square root of 85 also. So let's do it again. With this, I could draw a triangle knowing very well that this height is 6 and that is 7. So I'm going to do 6 squared plus 7 squared equals c squared. That becomes 36. That becomes 49 equals c squared. Add those two up and I get 85. No way! Which means these guys are the same length. So if these guys are the same length, that means these all are going to be the same length. It's a rhombus. Is it a rectangle? No. And here's why. If it's a rectangle, then this line has to be perpendicular to that line, which means the slopes have to be negative reciprocals of each other, and they're not. So it's not a rectangle, which means it's not a square. So we have ourselves a rhombus, but we don't have ourselves a rectangle and a square. That's it. Bye. What's crack-a-lackin'? Let's talk about rectangles. Now, we know everything about rectangles. It's a shape that we learned since we were little babies. But what we don't think about is slope and rectangles. I'm being asked to use the slope formula. Even though I have a nice coordinate plane here, I'm not going to use it. We are being asked to use the slope formula to determine if these 4 points make up a rectangle. Now, if it's a rectangle, 2 sides have to be parallel. Another pair of 2 sides have to be parallel, which means the slopes of parallel sides are the same. But not only do we need that, we need to determine if they're perpendicular. So what I'm looking for, now perpendicular slopes are negative reciprocals of each other. So this is what I'm looking for. I need 2 lines that have the same slope. I need 2 lines that have a different same slope. And are those different slopes negative reciprocals of each other? If they are, I have a rectangle. So let's just go in order. We have JK. So JK, here's my slope formula. Let me write it once up here, once alone. I think I have enough space. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to use the slope formula 4 times. I'm going to do JK first. And I will not say JK because I'm being dead serious. The slope for JK is going to be, let's mark these x1, y1, x2, y2. So my slope is going to be negative 6 minus 2 over negative 8 minus negative 10. We're going to do some mental gymnastics here, so as not to make this video a 20-minute video. Negative 6 minus 2 is negative 8. Negative 8, a double negative. So we've got negative 8 plus 10 is regular 2. JK is negative 4. The slope of JK is negative 4. It's 1. One of them's done. So we need KL. So where's my eraser? There you are. Let me erase this guy. I need KL. Do a different color. We'll call you X1, Y1. We'll call you X2, Y2. Maybe KL. M equals negative 3 minus negative 6 over 5 minus negative 8 we've got negative 3 plus 6, which is regular 3, and 5 plus 8, which is 13. So I'm done. Why am I done? These two are different. And so if they're different, then they would have to be negative reciprocals of each other. Last time I checked, 3 over 13 ain't no negative reciprocal of negative 4. So is this a rectangle? No. Again, the only way that this would have worked is we needed to get two slopes that were the same, two different slopes that were the same as each other, and those guys have to be negative reciprocals of each other because they form perpendicular lines, because it's a rectangle. That didn't happen because there's no negative reciprocal action happening here. We are done, we are done, we are done, done, done. I don't need to go any further. So that wasn't so bad. It really wasn't. I had fun though. All right. Bye.
Given the triangle with vertices A, 4, -1, so right there, B, 5, 6, so right there, and C, 1, 3, given those 3 points, I need to show that triangle ABC is an isosceles and also a right triangle. So this is a proof using coordinate geometry. It's not a 2-column proof. It's not a flow proof or an indirect proof. I am basically using the information that I have to prove what I need to prove. So it's not going to look like the regular proofs that you're used to doing. So I need to show 2 things. Thing number 1, that this is isosceles. Isosceles means that 2 sides are congruent. So according to my picture, it looks like these would be my 2 guys. I also need to show that this is a right triangle. So according to my picture, that's the guy that would look right. So the 2 things that I need to show are that BC and CA are congruent. Since these are coordinates, I'm going to use the distance formula. The second thing I need to show is that this is a 90-degree angle. So what I'm going to do is find the slope for BC and the slope for AC and prove that they're perpendicular. Okay? And I'm going to do that again using 2 main steps. So depending on what type of teacher you have, you may need to restate the given, but I don't have to. If I was your teacher, I would just ask you to show what you need to show and explain what you're doing. So I would want you to say something to the effect of, well, number 1, and I'm showing this part first, we need to show that BC, or CB, is equal to AC, or CA. Okay, I probably said it backwards at some point, but it all means the same thing. Now, this is coordinate geometry. So what we need to do is use the distance formula to find the length of each of these lines. And this is going to be the distance formula. Okay, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All of that in a big square root. So it doesn't matter which one. I'll show BC first. So I will explain that BC, I need to find the distance, and the distance is a big square root. Okay, let's say that B is our 2's and C is our 1's. So if I'm doing x sub 2 minus x sub 1, that is an x. So 5 minus 1. So 5 minus 1 squared plus 6 minus 3 squared. Okay, that's going to get me 4 squared, which is a fun game, plus 3 squared in square root. Still in the square root, 16 plus 9, which is the square root of 25, which is 5. So the length of BC is 5. Now I'm going to show that AC is 5. Or what did I call it? Yep, I called it AC. So AC, the distance, is going to use the distance formula again. So let's call you my 2's and you my 1's. So let's do 4 minus 1 squared, 4 minus 1 squared, plus -1 minus 3 squared. That's going to equal 3 squared plus -4 squared. 3 squared is 9. Negative 4 in parentheses squared is 16. Looking familiar? That's going to equal 25 in the square root. And the square root of 25 is 5. Okay? So distance formula out. So I will say, because I almost stopped right there. So I will say, so BC is equal to AC using the distance formula. Might be saying too much, but why not? Why the heck not? This one won't take as long. I could use the slope formula, but I'm just going to say we need to show that BC is perpendicular to AC. I have all this space, so I'm going to use it. Slope of BC is, now let's go up here. Let's find the slope. Up 1, 2, 3 over 1, 2, 3, 4, 3 over 4. And AC is down 1, 2, 3, 4, 1, 2, 3. So negative 3 over 4. The slopes are negative reciprocals. Okay, 3 over 4. Oh, wait a minute. This is supposed to be 4 over 3. Almost ruined the whole thing. The slopes are negative reciprocals, so BC is perpendicular to AC. Since BC is equal to AC and what was the other thing? BC is perpendicular to AC. Triangle ABC is an isosceles right triangle. Ran out of space there. Okay? Probably could have written out right, but it's too late. So there you have it. Kind of a mess, but and I almost screwed things up really badly over there, but that's how it's done. You basically just show whatever math you need to show to make sure that that works. And that's it. We did it. The vertices of quadrilateral KAIT are K, which is 0, 0, A, which is A0, I, which is A plus BC, and T, which is BC. Use coordinate geometry to prove that quadrilateral KAIT is a parallelogram. Well, there's several ways that you could prove something is a parallelogram, but probably the easiest way to do it is to show that you have two opposite sides are congruent. Two pairs of opposite sides are congruent. So if I were to imagine KA and IT, so that's kind of what I have to do. I have to do that. I have to show two pairs of opposite sides are congruent. So number one, I have to show that KA is congruent to IT. When I'm done that, I have to do AI and KT are congruent. Okay, so again, if you're like, I don't see it, I don't see the picture. Look, there's a picture, KAIT. It has to give you whatever order it's in. So I have to show KA and IT, and then I have to show AI and KT. That's what I have to do. So that's what I'm going to do. Okay? So I need to show that KA and IT are congruent. So the way we do that is we use the distance formula. Okay, so let's write out the distance formula down here. The distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so if I were looking at Ka, okay, we'll do this all in separate parts. Ka, I would say that the distance equals, let's let u be x sub 2, y sub 2, and let's let u be x sub 1, y sub 1. In fact, I'll write that out just once. I'll do this once, and then I probably won't write it out again because otherwise it'll get sloppy. 1, 1, 1, 1. You're supposed to be 1. All right, x sub 2 minus x sub 1 is going to be a minus 0 squared plus 0 minus 0, which is 0 squared. So let me get rid of this extra. Okay. That gets me a minus 0 squared. So I need my square root still. I don't know why I got rid of my square root. So square root a minus 0 is just going to be a squared plus 0 squared is just 0. So the square root of a squared is just a. So the distance of Ka is just a. All right, I can handle that. So the distance of it has to be a as well. So it, distance formula. Okay, let's let u be our 2's and u be our 1's. So x sub 2 minus x sub 1 is going to be b minus a plus b. B minus, now be careful. If I'm subtracting both a and b, it's going to be a minus b. I know that looks weird, but trust me. Plus c minus c, which is 0, so 0 squared. B minus b cancels out, giving me a squared. Plus 0 is just a squared. And again, the square root of a squared is a. So we did it. So since Ka is a and it is a, Ka is it. Thing number 1 proved. Now, Ka is it. Now I need to show ai is kt. So I'm going to say show ai is kt. AI, artificial intelligence, or Allen Iverson, my second favorite sixer of all time. All right, AI. Let's get rid of all this mess up here. I'm looking at AI, so let's let u be the 1's and u be the 2's. So x sub 2 is a plus b minus x sub 1 is a squared plus c minus 0, which is just c squared. A minus a cancel out, and that gives me just b squared plus c squared. Now let's not try to simplify that, because my goal is to make sure that kt is the same thing. So who cares if it's simplified? Who cares? Kt, that distance, big square root. So let's let u be my 2's and u be my 1's. So I have a feeling this one's going to be a lot friendlier because of that double 0. B minus 0 plus c minus 0 is going to be b minus 0 is just b, so b squared. And c minus 0 is c, so c squared. So we just showed that AI is KT, which means Kate is a parallelogram. And I believe the name of that theorem is the opposite sides something. I don't know. But since two pairs of opposite sides are congruent, it's going to be parallel. And there's a name to that theorem. It's escaping me because right now I'm recording this at 10:15 p.m. But that's how you do it. We proved it. All right. Coordinate geometry proofs. You just have to do the math. And a lot of times the math is fun because things disappear. That's what happened. Fun, 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 fun. The vertices of quadrilateral coat are C00, so let's just get these down. O50, O, A, which is 52, and T, which is 0, 2. Prove that coat is a rectangle. All right, so I have this picture here. Let me use a different color. I have this picture. In order for something to be a rectangle, all right, we need to show two main things. Thing number one, we need to show opposite sides are congruent. And thing number two, we need to show that all four angles are 90 degrees. Okay? Now, since we have a picture here, and since this is a rectangle and all of the measurements are super nice, we do not need to go crazy whipping out distance formula, or we don't have to go crazy whipping out slope formula. Okay, what I have to do is I just need to show that TA and CO are congruent. Then I need to show TC and AO are congruent. So let's do that first. Okay, let's do that first. And I'll say that. We need to show that TA equals CO, and we need to show that CT, or TC, I think I called it, is equal to AO. Okay, so let's do that. Pretty easy because everything lines up perfectly. TA is 1, 2, 3, 4, 5 units. So TA is 5. CO is 5. So TA is CO. Okay? If these lines weren't so pretty, I'd have to use the distance formula. I did that in previous videos, so if you want to go back and watch, I beg you. Also, TC 2, AO, which is what I do when I'm hollering out my friend, that's also 2, which means TC equals AO. So, opposite sides are congruent. Okay? What I'm going to do to show that these are 90-degree angles is I'm going to say what the slope of TA is, the slope of AO is, the slope of CO is, and the slope of TC is, and prove that all of these guys are parallel to each other because of negative reciprocals. So TA, let's actually word it better. The slope of TA, or let's do this. Let's be creative. MTA, that means the slope of TA is 0 because it's a perfect horizontal line. The slope of AO, which is what I do when I holler out to my friend, is undefined. The slope of CO is 0. And this slope of TC is undefined. What that means is TA is perpendicular to AO. AO, which is what I say when I'm hollering out to my friends, is perpendicular to CO. CO is perpendicular to TC, and TC is perpendicular to TA. So all angles are 90 degrees. Opposite sides are parallel or are congruent. All angles are 90 degrees. Therefore, coat is a rectangle. All right, so that's coordinate geometry proof. You're just proving what you need to prove to explain yourself. You're not making two columns. You're not flowing. Unless you're making a rap out of this, which all of those AOs sure sounded like I was flowing. Like and subscribe. Triangle art has vertices AB, which is A, R is A plus CB, and T is A plus C over 2, B plus D. Use coordinate geometry to prove that triangle art is isosceles. So something that is isosceles is going to have two sides that are congruent. And since I'm given letters instead of actual things to graph, I have to use the distance formula a bunch of times. So a little reminder that the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, all in a square root. Comes from the Pythagorean theorem. So let's see if I hit gold. I'm going to find the difference of A, or the distance of AR. I have to find the distance of RT, and then maybe I have to find the distance of AT. And I'm going to say that. I'm going to say, and I don't even, well, yeah, I'm still going to write out my steps. We need to show that two sides are congruent. So I need to find AR, I need to find AT, and I need to find RT, and hopefully the ones that I choose strike gold. So let's start out with AR. AR is going to give me a distance of big square root. Let's call you my x sub 1s. Let's call you my x sub 2s. So x sub 2 would be A plus C minus my x sub 1, which would be A. Things disappear, squared. Plus B minus B. How convenient. 0 squared. Okay? The A's cancel out. So this just becomes C squared plus nothing is just C squared. The square root of that, C. Okay? Okay. Let's try AT. I don't have a good feeling about it at all. AT is going to be D equals probably a bigger square root. Let's do that. Let's let that be my x sub 2, x sub 1. So A plus C over 2 minus A squared plus B plus D minus B. So B plus D minus B squared. Let's bring that root over. You go away. You go away. So that ends up being c over 2 squared, which is c squared over 4 plus just d squared. Let's leave it like that because it's not going to simplify any further. There's no tricks to find the square root of a sum. So let's leave it like that. Obviously, AR and AT are not the same. So I'm guessing that RT is going to be the same as AT. And if it's not, then it better be the same as AR. Otherwise, I wasted my time. So let's find RT. Retweet. Twitter, a dying platform. All right. The distance, let's let that again be my 2's, that be my 1's. So you're going to be A plus C over 2 minus, now be careful, I'm subtracting both A and C. So minus A minus C, close that, squared. Plus. I'm going to need more space on this one. B plus D minus B squared. You go away. You go away. All right. So this is going to be a tricky one. You ready? Maybe, maybe not. We'll see. What I have to do with this guy is combine the C over 2 minus C. And what I'm going to do is I'm going to turn this C into 2C over 2 so I can combine like terms. So minus regular C over 2 minus 2C over 2, close it, square it. You just become D squared, so all is well with that one. Okay, now I can combine these fractions. Okay, C minus 2C is negative C. 2 over 2 stays 2. That lives inside of a parentheses, squared, and you're still plus D squared. Negative C over 2 times itself is C squared over 4 positive plus D squared. If you're the praying type, you're saying right now, praise the Lord. Because AT equals RT, which means ART is Isosceles. I got really nervous starting this problem out, but we know that this is isosceles. We just have to make sure that our math proves it. And that's what we did. And so we wasted our time doing ARs, but aren't ARs a waste of time anyway? Oops, a political comment. Don't like and subscribe, I guess. Please do like and subscribe. Prove ABCD is an isosceles trapezoid. In order for something to be an isosceles trapezoid, you need to show two things. You need to show that these two sides are parallel, and you need to show that these two sides are congruent. So what I'm going to do is I'm going to find the slope of BC and the slope of AD and show that they're the same. Then I'm going to show the distance of BA and the distance of CD and prove that they're the same. Therefore, it's an isosceles trapezoid. Let's write out a few friendly reminders. The slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to come in handy for the whole parallel thing. The distance formula is a big square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so let's start out by doing the whole parallel thing. And I'm going to say that I need to show that BC is parallel to AD. So let's say the slope of BC, I'm going to use the slope formula. Let's let this be x sub 1, y sub 1. Let's let this be x sub 2, y sub 2. So y sub 2 minus y sub 1 is c minus c. I think I can handle that. Then I have x sub 2 minus x sub 1 is going to be b minus negative b. Double negative makes it positive. 0 over 2b is just 0. Makes sense because that looked flat to me. Now let's find the slope of AD. A similar thing should happen. If I call u x sub 2, y sub 2, and a x sub 1, y sub 1, then I'm going to do 0 minus 0, another toughie, over a minus negative a. Oh, look, a double negative. Let's make it a positive. 0 minus 0 is 0, over 2a is 0 again. So, since the slopes are the same, I have now proven that BC is parallel to AD. Okay? So that was thing number 1. Thing number 2 is I need to show that these two guys are equal in distance. So I'm going to use the distance formula to show that AB or BA is equal to CD. Compact disc, those of you 90s kids. D is equal, and let's rewrite it out so that I'm a little bit more specific. Let's start out with BA and show that the distance of BA is a big square root of, let's let you be my 2's and you be my 1's. So negative b minus negative a squared, negative b minus negative a squared, plus c minus 0 squared. Double negative makes a positive. Now, since space is an issue and time is money, okay, I'm going to use the idea of perfect square trinomials for this one, and I'm going to make sure that I understand that this becomes b squared minus 2ab plus a squared, and u are going to be c minus 0, which is just c, so plus c squared. If you're like, whoa, 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 what did he just do there? Perfect square trinomials. I'm not going to go any further than that because I know that when I do CD, that it's going to end up looking like the same exact thing underneath the square root. So what's the point of trying to clean it up? Okay, what's the point of trying to combine terms and simplify it? You probably can anyway. Let's keep that red going. CD, the distance for that, big square root again. I'm going to let you be my 2's, let you be my 1's. That is going to be c minus 0 squared. Oh, I did it backwards, didn't I? Doesn't really matter. Plus b minus a squared. C minus 0 squared is c squared, so there's my c squared. B minus a squared using perfect square trinomials is going to be b squared minus 2ab plus a squared. So there it is, the same exact thing. So, and let's get rid of these rules because I won't need them anymore, even though they look so darling. I just showed that BA and CD are the same. So let me say that. So since BC is parallel to AD, and since BA is equal to CD, that tells me that ABCD is an isosceles trapezoid. All right, so that's coordinate geometry. You're not setting up a two-column proof. All right, you're just showing the math that you need to show to prove that these guys are exactly what they say they are. Finally. A circle in the xy plane has an equation x plus 3 squared plus y minus 1 squared equals 25. Which of the following does not lie in the interior of the circle? All right, so let's understand what we're dealing with here. This is a circle. Generally speaking, right, you have the equation x minus, I'll use h. I don't know what letters people usually use, but I'll use, oh, forgot to swear it. Y minus k, let's square that, equals r squared. H and k are where your center of the circle will be. So if I were to draw this out to the best of my ability, this y plus 3 means that negative h is going to be positive 3. So positive h is going to be negative 3. So my center is going to be at negative 3. Y minus 1 lines up with y minus k. So negative k is negative 1, which means regular k is regular 1. Let's go up 1. My circle's center point is right there. 25 means that r squared is 25. So if I square root that, I have a radius of 5. So let's get a different color. My radius going to the right is going to go all the way out to 1, 2, 3, 4, 5. It's going to go all the way out to 2. Since I'm at 1, my radius going up is going to be up 1, 2, or actually 2, 3, 4, 5, 6. So up to 6. Going to the left, 1, 2, 3, 4, 5. So left 1, 2, 3, what is that? Negative 8 it goes up to. And 1, 2, 3, 4, 5 goes down to negative 4. So my circle is going to go like this and has to fall within this little range here. Okay, I didn't do the best job drawing out the circle. I'm just going to pretend that didn't happen. There you go. All right, so which of the points does not lie in the interior of the circle? 3, 2 doesn't. 3, 2, because 3, 2 is up here, and the circle's only going to go out to regular 2, so 3, 2 is not an option. 0, 0 worked. Negative 3, 1 is the center, and negative 7, 3 should work. But, you know, I definitely know that 3, 2 is not going to work. So I'm going to circle 3, 2, and that's going to be my guy, and I'm going to call it a day, baby. Identify the center, radius, and sketch. All right, so this is a circle because it mentions radius. Radii only live with circles, so that is the circle formula. This is the circle formula right here, actually. X minus x minus h squared plus y minus k squared is going to equal r squared. This is actually pretty easy. If negative, now my center, I'm jumping ahead. My center is hk. Negative h is positive 3, which means positive h is negative 3, so that's the x value of my center. Negative 6 is positive 4, so positive 6 is negative 4. There's my center. Now I need a radius. My radius squared is equal to 5. So if I square root both sides, my radius is going to be whatever the square root of 5 is, and that's 2.2 blah, 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 blah. Now, I'm not even going to try to draw this out, except that I am going to try to draw this out. Let's place my center at negative 3, negative 4. And then I try to draw out and around 2.2 units. So this is what the outside would look like. And then I would draw that picture around. Oh my gosh, I'm actually doing it. That's not bad. That's not bad. Here's what it's supposed to look like. Oh my gosh. Well, I mean, it's not perfect, but that's probably the best circle that I can whip up. But there you have it. So given all the information that we have, you can see, where my center is at -3, -4, and then a circle that's a little more than 2 around it. So yeah, I'll give myself a pat on the back. Do you hear that sound? That's me patting myself on the back. All right, we graphed a circle, boys and girls. Fun. Use the information provided to write the standard form equation of a circle. Well, the standard form equation of a circle is x minus h squared plus y minus k squared equals r squared. My center is hk. Well, that's nice. There's my h, there's my k. My r is, I don't know. But you know what I do know? That the area of a circle is pi r squared. So the area of my circle is 16 pi. So 16 pi is equal to pi r squared. And those pi's are useless because we can divide both sides by pi. If I take the square root of that, r is going to equal 4. Oh, so let's put all of this together, shall we? X minus h is x minus 15 squared, plus sign. Y minus k is y minus -8, a double negative. We'll deal with that in a second. And r squared is 4 squared, which is a fun game. By the way, we already found out that r squared was 16 a minute ago. Maybe I could have kept it like that, but who cares? X minus 15 squared plus y double negative is a positive 8 squared equals 16. That is a radius in standard form with a center of 15, -8, and an area of 16 pi, baby. Fun. Hi, everybody. Let's use Desmos to graph that quadratic right there. I wonder how it's done. Ooh, a quadratic. Y equals, now I'm going to type out -1/2 as you hit 1/2, move to the right and type out x. Now, there's 2 ways that I can add the quadratic part to this. I can click on the keyboard and hit second. Or the other way that you could have done it is you could have hold down shift, hit 6, and that would allow you to do it right there. But that's my quadratic. It's a parabola that opens down. It opens down because the number in front of x is negative. It's a little wider than normal because of the half. And, if I need to get some points, I can kind of hover over it, click on it, and go where I need to go and get some points that might look important if I'm putting this on a coordinate plane myself. There you have it. Wow. I'm going to leave it right there for a few more seconds for you to enjoy. Okay, thanks for watching. Bye. Hi, everybody. Let's use Desmos to graph a quadratic in vertex form. I wonder how it's done. All right, graphing an equation in vertex form. I wonder if there's going to be any similarities in the equation and the picture. Probably. -1/4, -1/4. Move to the right before you start typing out parentheses. X minus 1 inside the parentheses. You can get squared by clicking the keyboard and hitting squared right there, getting rid of the keyboard, or you can hit the little caret button, which is Shift 6. That'll do it for you too. What's next? +4, and there's my picture. So you can move it around if you need to. Hit home when you're done. But you could see some pretty important areas. If I click on this guy, I can see my vertex, which is 1, 4. So you could see 1, 4 hiding in the equation. This is opening downward, and the reason why this is opening downward is this whole thing starts out with negative 1/4 attached to my parentheses. That's what makes it open up downward. It's kind of wider because 1/4 spreads it out. But yeah, there it is. I mean, we can go throughout this whole thing and get some pretty important points if we want to graph this. So yeah, there's your equation in vertex form, baby.
Oh, wow, that's pretty cool. I'm going to leave it right there for a few more seconds for you to enjoy. I enjoy you. I hope you enjoy me. Thanks for watching. Bye.
Identify the vertex, focus, axis of symmetry, and directrix of this guy right here. Then I have to sketch the graph. All right, I have a y that's not squared and an x inside of a parentheses that is squared, which tells me it is a parabola. Now, what is all this other stuff? Well, if I were to draw just some random parabola right there, focus lives inside the curved part of the parabola. That's the focus. The vertex is the minimum or maximum, and then equally distant is going to be a flat line called the directrix. Okay? Now, I'm going to have to draw all this stuff out at some point. Not quite yet. Let's just focus on one thing at a time and finding stuff out. The x part is squared. There are parabolas where the y part is squared, so make sure when you're looking for the formula that you compare this to, you use the right one. This is the standard form of a parabola where the x part is the one that's squared. X minus h in parentheses squared is going to equal 4p, and if you're like, p, what does that stand for? You'll find out. Y minus k. I need to make that look like that. So what I'm going to do first is I am going to flip things. Let's just completely flip everything. We've got negative x plus 3 squared. I'm actually going to keep, now I'm going to still flip it. Minus 1 is going to equal to y. Okay, now what I need to do is I need to get all the y stuff on the right side. So let's add 1. So negative x plus 3 squared. Let's add 1 to both sides. So now I have y plus 1. Let's throw a parentheses around that just for funsies. And let's multiply both sides by a negative. So what we have is x plus 3 squared equals negative. And I'll put negative 1 even though I don't need to. I'm multiplying everything by a negative. There you have it. Now I can compare that to that. It's important to know that I have to find what? The vertex, the focus, and the axis of symmetry, and the directrix. Okay, well, the vertex is going to be HK. So the vertex in this case is going to be H. Now, negative H is positive 3 here, which means positive H is negative 3. So H is negative 3. K, similarly, positive 1 is negative K. So positive K is going to be negative 1. Okay, that's my vertex. Let's get a different color. My focus is found by taking H and then K plus P. You might be thinking, what's P? I still have to figure that out. In front of the parentheses here, I have 4P, and this is negative 1. So comparing this to this, I'm going to let 4P equal negative 1. So if I divide both sides by 4, P is negative 1/4. So my focus is H, and I already know that my H is negative 3. K plus P is going to be negative 1 plus negative 1/4, so negative 1 1/4. All right, so what I have so far, let's circle things out, is my vertex is there. My focus is there. My axis of symmetry is going to be a vertical line that cuts through the vertex. So my axis of symmetry, since it's going to be a vertical line, is going to be x equals. Well, if it cuts through the vertex, then x equals right there, -3. So that is my axis of symmetry. Last but not least, my directrix is going to be a horizontal equation given to us by y equals k minus p. K was -1. P is -1/4. So to round things out, y equals -1 minus -1/4 is the same as -1 plus 1/4, which is going to be -3/4. Now I know I'm going to do a terrible job drawing this out. Okay, I'm going to do a terrible job. So what I'm going to do is I'm going to paste the picture that I'm supposed to have. Did it work? Did it work? I don't think it worked. I don't think it worked. Let's try it again. Copy, paste, and it didn't work. All right, let's try it this way. Let's try copying it like this. This makes for very good podcasting. All right, I captured it. Let's go back over here. There we go. All right. So, why is it upside down? Because this is negative. That's thing number one. Okay, let's label this picture a little bit. My vertex is -3, -1. So my vertex, my vertex does live right there. Okay, my directrix right here is y equals -3/. So it's like a little dashed line, like kind of like right there, whereas my focus is -3, -1/4 lives right there. Okay, so we can kind of see everything falling into place. My axis of symmetry is x equals -3, so there's my vertical line that goes through -3. So we could see everything there, directrix, axis of symmetry, focus right there, vertex right there. So everything lives where it should be. And if you're wondering, well, how can I get points to make a graph? Just plug random points in. If you know what your vertex is and it's -3, -1, then plug in -2 and see what y value you get. Plug in -1 and see what y value you get. And whatever you start graphing over here, the same exact thing is going to happen over here because this acts as a mirror image. So graphing parabolas when they're in this standard form is never fun, but you know, we did it, and I had a great time. Parabolas.